Hello students, in this video let us discuss one more question. This question from JEE Main 9th January shift 2, that means evening session. So this question is based on the electrophilic addition, nucleophilic addition and mostly based on stereochemistry. Okay, of course regarding the stereochemistry in first year textbook is not given, but so this question is almost more than JEE Mains level. So here you can see this question. So which of the following reactions will not produce a racemic product? Okay. So you see this one. The first one is uh, protonation of this double bond. Okay, protonation of this double bond. So let us discuss what is the racemic product. The racemic product is nothing but it is a mixture of two enantiomers. For suppose here you can see these two are the enantiomers. Let us say this is the carbon, chiral carbon, different groups, the chiral carbon, different groups. These two are the mirror images each other. So the mixture of two enantiomers is nothing but racemic mixture. Okay. So actually here in a chemical reactions, racemic mixture is formed as a product. We are very familiar with the SN1 reactions. In SN1 reactions, carbocation is the reaction intermediate. So that is a planar. So in case of any planar species that is furtherly attacked by the either nucleophile, so your front side and back side attacks are possible. We'll get the two different compounds, nothing but a mixture of two different compounds. These two are the enantiomers. That mixture is known as a racemic mixture. So here in this case, first of all, protonation CH3 and CH3 hydrogen and CH bond CH3. So now this one carries a positive charge. So now here this is a secondary carbocation. The secondary carbocation the less stable and there is a chance for the getting more stability by H minus migration. So here CH3 and this CH3, this one plus and CH and CH3. Now this is the tertiary carbocation. This is the more stable carbocation than the secondary carbocation. Why? Because this one has only 4 alpha hydrogens. That means here 4 hyperconjugate structures. But in this case, this one has a 2, here 3, here 3. So 8 alpha hydrogens, 8 hyperconjugate structures are possible. So this carbocation is more stable. Now it is attacked by the Cl minus furtherly. So we will get here only single product. That means here a racemic product is not produced. Why? Because it's not a chiral carbon. Okay, so there is no chiral carbon, there is no optical activity, so there is no formation of the racemic product. Okay, that's it. That means here we have to explain with respect to the major product. Okay, so generally we are considering only major products which are formed in a chemical reactions. Of course, if you consider this secondary carbocation, actually here from this secondary carbocation also we will get the product. Of course, but that is formed in a minor quantity, but this is the major product. So major product is optically inactive. That is not a racemic product. It is a single compound. But if you consider this secondary one, that Cl minus attacks on this one. So here this produce your hydrogen and this is methyl and this is chlorine. So it is a now chiral carbon. So as a result here in this case, two products are produced. That means nothing but racemic mixture. Of course, you should not consider this one because it is a minor product actually. This is the major product. So consider the major product. Okay, to explain the formation of the racemic product. Okay, now here consider this carbonyl compound. So actually here this carbonyl compound. So 2-butanone. Okay, 2-butanone on reaction with the HCN. It is a nucleophilic addition reaction. So initially this compound is a planar compound because this one, of course, here this carbon is the sp2 carbon, so planar one. So this planar group, that means CO, is attacked by the Cn minus either front side or back side. So as a result we will get the two products, that means here OH and Cn. It is a chiral carbon now, here methyl OH ethyl Cn. So here we will get the two products, dextroisomer as well as levoisomer, is nothing but racemic mixture. Okay, that's it. So here next one, again electrophilic addition reaction by that means by pi electrons transfer. Here this H plus attacks on this one. So here we'll get the stable carbocation tertiary CH3 plus and this one CH3. Now here this one attacks on Cl minus. So here the product is CH3 and Cl and this one CH. Now in this case here, this is the chiral carbon and this is the chiral carbon. This compound contains two chiral carbons. Initially the configuration of this chiral carbon is not mentioned. Okay, that may be above the plane or below the plane. Okay, that is not clearly given. So but here in this case, here the configuration of this carbon is not clearly mentioned. That means either may be above the plane or below the plane. So now in this case it is a chiral carbon, it is a chiral carbon. Totally two chiral carbons and this compound is an unsymmetrical compound. 2 power of 2, 4 isomers are produced. Okay, so here from this one I am writing like this here. So here above the plane methyl and this is methyl above the plane and this chlorine below the plane. Okay, or suppose here I am starting with this reactant. Okay, so here in this case another compound may be produced. Here its configuration is fixed and now here this methyl is maybe below the plane and this chlorine above the plane. Okay, so that means here if I starting with this reactant. Okay, so for suppose that methyl may be below the plane, methyl may be below the plane. So in this case again two are possible, CH3 and Cl. Here I am writing possible products. So here this one methyl below the plane, here methyl above the plane and Cl. Why here I am writing like this here? Because this is a carbocation planar that is attacked by the either front side or back side. So we'll get the two products. Okay, at this carbon fixed configuration. Now here and possibility of another product, here methyl below the plane and here chlorine above the plane. So this methyl is below the plane fixed. Now here we can see clearly these two are the mirror images each other and these two are the mirror images each other. Okay, here above the plane, below the plane, methyl above the plane, methyl below the plane, and chlorine below the plane, and chlorine above the plane. These two are exactly mirror images, and these two are exactly mirror images. So here there is a formation of the racemic mixture. That means two enantiomeric pairs are produced in this reaction. Of course, generally we can predict like this here. These two are the chiral carbons, so 2 power of 2, 4 isomers are produced. Among the 4 isomers, there are the two enantiomeric pairs. So in this reaction, there is the formation of the racemic product possible. And next here finally that again in the alcoholic addition reaction. So here CH3 and CH2, CH bond CH2 like this. Transfer of electrons takes place. So here CH3 and CH2, CH bond CH3 plus. Okay, again this is a carbocation attacked by the Cl minus. There is a generation of the chiral carbon. Okay, that means here there is a racemic mixture formation takes place in this reaction also. Okay, that's it. So here in this one, so finally that whichever following reaction will not produce the racemic product, the answer is the first one. That means regarding the formation of the major product. Okay, so in this case racemic mixture formation, and in this case also takes place, and fourth case also clearly we can see racemic formation, racemic mixture formation. Okay, that means here of course here that formation of the racemic mixture is nothing but the racemization we are saying generally. Okay, racemization means here that initially this compound is optically inactive compound, but optically inactive compound is converted into racemic mixture. So here in this case that phenomenon is known as a racemization. For suppose this compound is optically inactive, but that is converted into racemic mixture, so that phenomenon is known as a racemization. Okay, That's it. For suppose in this case, I am writing like this here, methyl, and here C2H5 ethyl, and this one OH and CN, or maybe OH and CN, CH3, C2H5. These two are the mirror images each other. Okay. These two compounds are formed in equal amounts. Why? Because that Cn minus attacks on this carbon either front side or back side. So you'll get the racemic mixture. There is nothing but racemization. Okay. Thank you. Thank you for watching. Please subscribe my channel.